It is Mr. V here from Plainfield Central. Going to take you through this review here, get you ready for your test. So for number one, we need to come up with an expression that talks about this sequence going on here. So easy way to do it is just come up with a little table here. So the first figure had 3 toothpicks, then the second figure had 5, and so on. Looks like we're adding 2 each time. So the original way we learned how to do it was to look at this column over here. Notice it starts with 3 and then we're adding 2 each time. So we had 2 once, add 2 2 times, add 2 3 times. And if you compare this number over here in parentheses to the number of the figure number, notice this is always 1 less. That's why we're going to say n minus 1. And after we distribute the 2, simplify, this would be our expression. So in other words, I can figure out how many toothpicks there are. All you need to tell me is what number figure you're talking about. So if I tried 4, 2 times 4 is 8, 8 plus 1 gets me 9. Or the shortcut to go straight from here is to see they're going up by 2 each time. So that's where that 2 came from. And then you choose one of these points here, so let's try 1, 3. 2 times 1 is 2. What do I need to add to it to make it into a 3? Add that 1 right there. And that works for all of them. Okay. We've got a bathtub full of water, 36 inches deep. Plug gets pulled, and we need to come up with an expression. So this here is the expression. Here's your starting value, and we're going down. It's decreasing 6 inches every minute, and there's a number of minutes it goes by. So after 1 minute, we are down to 30 inches, and down it goes. But if we want to come up with the equation, I should say equation there. If we want to come up with the equation when it's empty, well, how many inches are left in there when it's empty? It's 0. So then we just solve there, so that means after 6 minutes the tub would be completely empty. Alright, Xander's getting some tacos and a pop. So how much does this cost him? Well, this over here is the expression for the cost. So it's $2 for the pop and then $6 for every taco. So T represents how many tacos he's going to buy. So here's how much it costs, and it says that the total order was $21.50. So you get to solve for T, subtract 2 from both sides, divide by 6, and you get that each taco was $3.25. Okay, now we're just solving equations, variables on both sides. So you always simplify on the left, can't do anything there. Simplify on the right, can't do anything there. Now we get our variables to one side. I always bring them to the side. It's got the coefficient that is more positive, so that's -2. Get rid of a -4x by adding 4x to both sides. Add 1 to both sides. Divide both sides by 2. X equals 3. Okay, we got 2 lawn companies. So anytime we got a word problem and there's 2 companies or 2 people, always just get a visual, right? Company A, Company B. What do we know about Company A? Well, they charge $2.50 no matter what, and then $10 for every square foot. Company B charges $90 and $12 for every square foot. The question says write an equation that represents the number of square feet. Oh, that should have been an N. That's fine. When the 2 companies charge the same amount. Well, same amount means when this cost is going to be equal to this cost. So set them equal to each other. Then, just like last problem, we have variables on both sides. Get them to the side that's more positive. So subtract 10f from both sides. Get your like terms together. Get that 90 out of there. Subtract 90. Divide both sides by 2. So 80 square feet. Well, what does that mean? Well, in order for this cost to be the same as this cost, one of the 2 companies charge the same amount when there's 80 square feet. Alright, solve the equation, justify what you're doing. So we always try to simplify first. And we get parentheses, we need to distribute. So 2 times x, 2x, 2 times -1, -2. So that was the distributive property, and now we're going to combine these like terms, and then get all your variables together. Subtract 5x, subtract 5x. We do that because of the subtraction property of equality. Same thing here. Get this variable term by itself by getting that +4 out of there by subtracting 4 to both sides. And then divide by 4, So it's a different division property of equality, and then your final answer is going to be negative 3/2, which is the same thing as negative 1.5. Alright, so Joe babysits and he walks dogs. Alright, so right away I say, okay, babysitting, walking dogs. What do I know about each of them? So $10 an hour babysitting, $5 per hour walking a dog, okay. He earns tips. So, all we know right now is that last week he spent 6 more hours walking dogs and babysitting. So I don't know how many hours he spent babysitting, but I do know walking dogs, he did 6 more than whatever he did babysitting, the hours spent babysitting. Okay. So now we got to talk about when did he earn the same for each job? Well, same. That's we're going to set them equal to each other. So this represents how much money he made babysitting. So he made $10 for every hour babysitting, plus the $5 in tips. And then over here, he what's going on here? So he did. He gets $5 for every hour walking dogs, and we said this represents how many hours he's walking dogs, because that's going to be the whatever he did babysitting plus 6, and then plus his tips over there. And then the next part says we want you to solve for H. So that'll tell us how many hours babysitting, and then we can figure out how many hours spent walking dogs. So once again, distribute the 5, combine like terms. Get your variables to one side, subtract 5h from both sides, and then finally divide both sides by 5. H equals 5, and since we said h represents the number of hours babysitting, so that's why it's 7 hours babysitting, and then whatever 7 plus 6 is, 13 hours walking dogs. Okay, so you're going to buy some oranges and pears, so right away I write oranges and pears, and I say, okay, I need to figure out what kind of expressions can I put for those. All we know is that a pound of oranges is $2 less than pears. So if we call the number of pounds of pears P, we know what oranges is going to be, actually that's going to be the cost of the pears, right, per pound. So this is going to be 2 less than that. So if I got 10, what do we get here? 10 pounds of oranges. So 10 pounds, well how much does a orange cost per pound? Oranges per pound? Well it's going to be P minus 2. And then it says together it costs $61. So I'm going to add these two expressions. And then what do we got here? So 8 pounds of pears. So here's pounds of pears. How much do those cost? So distribute the 10 and get your like terms together. 10p and 8p make 18p. Add 20 to both sides. Divide both sides by 18. You get p is equal to 450, and that's how much the pears cost per pound. So pears are $4.50 a pound. Oranges are going to be 2 less than that, so $2.50 a pound. So lesson 2.4 was no solution and infinitely many solutions. Remember, no solution is when you work the problem out just like normal, and then you get to the end and it doesn't make any sense, right? Like here we got 6 equals negative 6. So you can see it right away. You get a 12x on both sides, but you had a 6 and a negative 6 there. So if we just tried to solve like normal, subtract 12x from both sides, we get an equation. Doesn't make any sense here, so we're going to say no solution. Then the other one it could be is infinitely many solutions. So that's when you work the problem out and you get something that you get a true statement as opposed to a false statement. So once we distributed, we get our like terms together, 6x and 2x. Notice we have the same exact thing on both sides of the equation. Right there we could say that there's infinitely many solutions. But say we didn't recognize that, we solve like normal. Subtract 24 from both sides, divide both sides by 8, and then you get a true statement here, x equals x. When we solve literal equations, remember a literal equation is just an equation with more than one type of variable. Like here we have an A and an H and a B1, B2. Here they're saying solve for this B1. So we're trying to get B1 all by itself. That's the whole thing there. So the first thing I'm going to do is get rid of that 1/2 that's being multiplied out front. So multiply by its reciprocal, 1 over 2. Reciprocal of 1 over 2 would be 2 over 1. Multiply that in both sides, 2a over there. Now this is h times this quantity over here, so I can just divide by that h. So now I get 2a over h equals b1 plus b2. Now, how do you get rid of this variable right here? Subtract it from both sides. Since these are not like terms, I'm just going to write it just like I read it. 2a over h minus b sub 2. Okay, graphing inequalities. So here, this is a less than symbol. So this is less than, less than or equal to, greater than or equal to. So if they don't have that or equal to, we do an open circle, and that shows that whatever number it is, that is not one of the solutions. So here, we're showing all the values of x that make this a true statement, and they're all less than -3. So I'm showing that with an open circle, which means that it cannot be -3, but it could be all the values that are less than -3. And then we would do a closed circle if it's or equal to, because that means it could be that number. It could be equal to it. Okay, now we're coming up with inequalities from a word problem. So Molly buys a notebook for $1.59 and then a bunch of pencils that are 15 cents each. Now this represents the cost. This is the expression on this side. So when you buy something, it needs to be less than or equal to the money you have. So if she's got $5, here's our inequality. Solve for P, the number of pencils. And the number of pencils has to be less than or equal to 22.73. We can't get 0.73 of a pencil, so the value of P is less than that number. The next whole number that is less than 22.73, 22. Alright, let's solve the inequality here. Got to distribute the -3, so -3x and a -6. Get your like terms together. Here I'm going to leave the variable on the left side, subtract 6 on both sides. Now the one thing about inequalities is whenever you divide or multiply by a negative number like we're about to do here, you need to flip that sign. So greater than becomes less than. Because it's just less than, not or equal to, we do an open circle. All the values of x that are less than -1 is represented right there. And then for this one here, same thing, distribute -2. Get your like terms together. 4 minus 2 is 2. This time I'm going to leave the variables on the left side. No, I'm not. I'm going to move them to the right. Now because I didn't divide by a negative, I didn't have to flip that sign. So once I solve for x, I'm getting -8 is less than x. The other way you can read that is the other way. So coming from the right, I would say x is greater than -8. So x is greater than -8. Whenever I got to graph these, I'm always going to rewrite it whenever the variable is on the right side, because it's a lot easier to graph now. Because when the variable is on the left, the arrow points which way we need to shade. Because we're shading all the values that are greater than -8, which is represented over here. Another way to think about it, -8 is less than all my solutions. Well, there's -8, which is less than all these solutions. Compound inequalities. So these are the and or problems. This one is going to be an and problem. Remember, if it's an or problem, it'll say or in the inequality, just like it does here for the next problem. So here I need to show all of the solutions that are greater than or equal to -3 and less than 6. So they're kind of all smushed between those two numbers. Now it could be a -3 because of the or equal to, so that's why it's closed circle. Can't be a 6, that's why I do an open circle. But all the values in between represented by shading in between those 2 points. This compound inequality here, it says, or, which means, so once I solve here, distribute the -3. Solve for x, notice I had to divide by a negative, so greater than becomes a less than, need to flip my sign. So all the solutions are less than 38/3 or greater than 18. So if I were to graph that, the shaded areas would be going in opposite directions. Okay, absolute value equations now. Remember, an absolute value is just the distance from 0. So how far away is, here we're starting at 0, there's our starting point. and then this number over here says how far you go in each direction. So if you're starting at 0, you go 6 to the right, you land on 6. You go 6 to the left, you land on -6. And we could always plug those values back in to make sure it makes sense. The absolute value of 6 is 6. The absolute value of -6 is also 6. Now when we're solving these, the first thing we need to do is get the absolute value all by itself. In other words, this guy's got to go. So I had to get rid of a -3, add 3 to both sides. And once you get here, so the intuitive way to think about what the solutions are going to be, remember if we're going to look at a graph, we need a starting point, which is always the opposite of this number right here. So the opposite of 7 is -7, so we're starting at -7. Remember this number is how far we go to the right and to the left of that starting number. So we're going 8 in each direction. -7 plus 8 is 1. -7 minus 8 is -15. But that's a lot of work, so we talked about how do we solve these without looking at a number line. So once we get the absolute value all by itself, so there's just an absolute value on the left side, we can split it up into 2 equations. The first one's easy. It's just rewriting the original, only no absolute value. The next one, same exact thing as the last one, only this time, whatever's on the right side, we're going to take the opposite of it. So we're going to have a -8. And then you solve each, and you notice we're getting the same solution we got from doing it with the number line. And then they get a little more complicated, but this the method is always the same. Get the absolute value all by itself before you can even think about solving, right? So we had to get rid of a 9. You do that by subtracting 9 from both sides. 15 take away 9 is 6. Now once you have the absolute value all by itself, once again you split it up in 2 problems. The first one is just rewriting it but no absolute value. The second one's exactly the same, but only this time it's the opposite of whatever you had on the right side. And then you need to solve both of those equations. So we're getting x equals -1/2 and x equals -7/2. So if we were to put those on a number line, -1/2 and -7/2 would be -3.5. Okay, now we solve absolute value inequalities, not equations. Alright, so when we solve these, we're going to break it up in 2 problems, just like we did for the equations. Only now we have 2 inequalities, not 2 equations. And just like last time, we are going to take the opposite, so drop the absolute value, and for this one we take the opposite. The only difference is now, so this one here is exactly the same, but this one over here, one thing extra you have to remember is whatever that symbol was, you need to flip it. So less than or equal to becomes greater than or equal to. Now this is going to become a compound inequality, and the way you remember it is if the original was a less than or equal to, or just a straight up less than, the way to remember it is less than. Alright, so we know it's an and problem. And the next one here, this is a greater than symbol, and the way you remember that is greater, so it's an or problem. So less than is an and problem, greater than is it turns into an or problem. And then once again you just solve, and so all the values of x are going to be in between -3 and 11, because x has got to be greater than -3 and less than 11. So this one we're going to solve, and then we have to graph it. So once again this is greater, remember, great or, so it's an or problem. So the absolute value is all by itself, so now I can split it up. First thing I do is rewrite it, no absolute value. Second one, rewrite it, no absolute value, but only this time we need to flip the symbol and take the opposite. And then we just solve each of them. So I add 7 to both sides, divide both sides by 2. X has got to be greater than or equal to -1, which is expressed over here. And then subtract 7 from both sides, divide both sides by 2. X has got to be less than or equal to -6, which is represented over here. Alright, Rugrats, good luck on your test.